In this video, we are discussing about light. So basically, light is a energy packet. Like it's a combination of a very small packets. We combine together. We say it's a light. And there are so many other definition of light as well. So light is a wave. Some people say light is a particle. So based on that two theory, we have a two theory of a light. One is wave nature of a light, another is particle nature of light. If we can relate that theory a bit, just like one human being is there. So human being can do so many things, like they can act in movies, they can play cricket, they can go for sport, they can go for election, they can be politician, anything. Like human being can do several things. But if you see the overall structure of all human being, it will be same. Obviously, I am not talking about DNA and gene type of thing. So everybody have a different one. So overall structure of all human being, if you see all organs will be same. Human ear, eyes, heart, kidney, everything will be, all organ will be same. Like I'm not talking about that DNA part of thing. So human being can do several things. And every human being have a similar structure, almost similar structure. I am telling almost similar structure because that minor part I don't want to go for genetic structure and all the things. So similarly for light, if you can relate that analogy over here. So what's analogy over here? Light can do several things. Light can form image, it can generate heating sensation, it can create energy, it can excite electron. So whatever light can do, that part of this chapter we say it's a ray optics. If you are studying what light can do, that is called ray optics, or some book it's a written geometrical optics. Both are same thing. Ray optics are as geometrical optics. Both are same thing. What light can do, but light have some structure. So light internal structure, if you want to study, that is called wave optics. And some book it's also written this is physical optics. So wave optics are as physical optics. So simply I am telling one thing, if we are studying whatever phenomena light can do, whatever event light can do, light can facilitate, that is called ray optics. And what is internal structure of a light, that is called wave optics. So in 10th grade syllabus we never talk about wave optics, we only focus about ray optics, means what light can do. It can form images, it can create heating sensation and so many other things and all. So if you are talking about light, it means we are talking about ray optics. So we are talking about ray optics, and ray optics means image and object. Simply light form images. So ray optics means image and object, and we are making so many assumptions to do this chapter. If we want to do this chapter, we are making so many assumptions. We assume that light is combination of so many tiny particles. We assume that, and we also assume that light move on a straight line. Obviously it's not, but we assume that light move on a straight line, and it's a combination of so many tiny particles. So there is one law to explain this particle nature of a light. So that first law we say it's a law of reflection. This is law of reflection. Reflection means it bounces back in same medium. If something is bouncing back in the same medium from where it started, that is called reflection. For example, this is one mirror. This mirror is there, and if I draw one line on this mirror, that line is called normal. Obviously this line is perpendicular on this mirror, this line is normal. So this is normal line. And if light ray strike on this one at angle theta, let's say this angle is theta, okay, let me this angle is I, and light ray will reflect back like this. This angle is R. So this is called incident ray. This one is called reflected ray, and this one is called normal. Means this is one mirror, this one is one mirror. Perpendicular to this mirror, whatever line is there, that is called normal. Whatever light ray is striking on this surface, that is called incident ray, we represent by I. And whatever light ray reflecting from this surface, that we say reflected ray. So what is law of reflection? Law of reflection mention 2 points. First point, incident ray, reflected ray and normal. Means this one incident ray, this one reflected ray, this one normal. They will be on the same plane. They will lie on same plane. So incident ray, reflected, normal will be on same plane. What's the meaning of this? Simply meaning of this one, this diagram won't be 3D, it won't be 3-dimensional, it will be 2-dimensional, means everything should be on the board. See, this, if I put this hand like this one, it's a 2-dimensional. If I put hand like this is 3-dimensional. This is going somewhere here. This one is going somewhere here. So everything means whatever light ray there, incident ray, normal and reflected ray, everything must be there on the board, means must be there on the one plane. It should not be 3-dimensional. That's the meaning of a first law of refraction. So this is first law of refraction. I mentioned this one by A. So better you mention this thing by first law. This is the first. This one is first. Now what is second law? Second law of this one is angle I is equal to angle R. This I is equal to R. Means angle of incident is equal to angle of reflection. What is angle of incident? Angle between incident ray and normal is called angle of incident, and angle between refracted ray and normal angle of reflection. So what is the first law of refraction? First law of reflection is I, R and N. What is I, R and N? I incident ray, R reflected ray and normal. So they will be on the same plane. And second, this angle of incident should be equal to angle of reflection. So I is equal to R. So this is law of reflection. So we continue this one for the next topic. But before that, I'll just explain one thing about object and image. Basically, I don't think that concept will be there in the NCERT, but you must know this thing. What will be object and what is image? So obviously we know what's the object. Anything that contains space, that is object. But I'm not talking about in that general perspective. I'm talking about specifically about this one, light. In light, what will be object and what will be image? So if you are specifically talking about light, in that case object means intersection of incident ray and image means intersection of reflected ray. What does it mean? If I take one plane mirror over here and intersection of incident ray, we say object. Means object is defined by incident ray, and intersection of reflected ray is called image. It means image defined by reflected ray. So incident ray means incident ray defined object, means intersection of two or more than two incident ray, we say it's a object. And reflected ray defined image. So intersection of two or more than two reflected ray, that define image. So object defined by incident ray and image defined by reflected ray. I'll give an example for that one. Let's say these two rays going like this. So these first and second, these two are incident rays. So obviously where they will intersect at this point, it means this one is what? Object. And we know law of reflection. So law of reflection is like this. So it will go in this way and this one will go. This is normal. This one also normal. So if I extend this line, it will intersect. It appears to intersect at this point. Actually, it won't intersect. It appears to intersect at this point. So if we see 1 and 2, these two are incident ray. But if we see 3 and 4, these two are reflected ray. Incident ray define object, reflected ray define image. So these 3 and 4, these two are reflected ray. It means this one is what? Image. So in physics, object means intersection of incident ray. Image means intersection of reflected ray. So more specific example if I give over here, let's say these two rays are there. This one. Now these two are incident rays. So these two are incident rays. Obviously they cannot intersect left hand side. Like here they cannot intersect. Obviously if they will intersect right side. But there is a mirror in between. So obviously they cannot intersect. So while extend this one by a dotted line, Now if we see this 1 and 2, these two lines are incident rays. So this one is what? Object, and this is called virtual object. So this one will be out of context bit, like for 10th date it will be out of syllabus, it will be like higher version of that one. So right now this is virtual object. Just assume something called virtual object. Later on in 12th grade we'll do virtual object. Why it's a virtual? Because this is incident ray, they cannot intersect, but it appears to intersect at this point. That's why we are telling it's a virtual object, and obviously it will reflect back in this way using law of reflection. So if you see 3 and 4, this 3 and 4, this ray 3 and 4, these are reflected ray. It means this one is image. Here if you see, this is object, this one is image. Object is real, image is virtual. Here if you see, object is virtual and image is. So what is virtual object? That is separate topic. It's not in your syllabus, and something it will be in 12th grade or something called JE and JE Advanced, something like if you want, right? So that time we need this concept. But just you remember one virtual object type things will be there in the plane mirror. So real object, virtual image. Virtual object, real image. So this one is object and image, and law of reflection also we did. And intersection of incident rays, object, intersection of reflected ray, image. Now using that law, if I want to find out where will be image position and where what will be like size of image, what will be magnification, so we can use that one for ray diagram. But before that ray diagram, we know two types of mirrors are there. Basically 3 types of mirror we take. One is concave mirror, one is convex mirror, and one is plane mirror. So if I make this mirror, so you will say this one is concave, this one is concave mirror. One surface is like elevated surface will be polished one, and if elevated surface is not polished one, means this one is concave, this one you can speak it's a convex, and this one you can speak it's a plane mirror. So this one is concave mirror, concave, and this one convex mirror, and this one plane mirror. So if I make a ray diagram for concave mirror, convex mirror, so there are certain sets of rule, and that rule you have to follow to make a final image of a concave mirror, convex mirror or plane mirror. So what are the sets of rule? First rule is that rule number one, if line passing through focus, it will become parallel to principal axis. Any line passing through focus, it will become parallel to principal axis. So this is rule number one. I am telling it's rule number one. If you see any other book, NCERT, and it might be that numbering will be interchanged. Fourth one might be first, and first one might be third. But number of rules will be 4. Total number of rules will be 4. So I am telling rule number one is, if light ray passing through focus, after reflection from mirror, it will become parallel to principal axis. See, this is mirror. This is mirror, and name of this mirror obviously we know it's a concave mirror. So this axis is called principal axis, and where this axis will cut this one, this is called pole of the mirror. Now if this one is center, so half of that center is focal point. So this is the focus of a mirror, this is center, this axis is principal axis, and this one is pole. What's the first rule? I am telling, if line passing through focus, means it's a passing through focus, will be parallel to principal axis. If any line passing through focus, it will become parallel to principal axis. What's the meaning of this? This line is passing through focus. If you see that, this line is passing through focus. This is the focus. and it becomes parallel to principal axis. This is rule number 1. Any line passing through focus, it becomes parallel to principal axis. This is rule number 1. Now rule number 2. If line parallel to principal axis, it will pass through focus. Means ulta of this rule number 1. Rule number 2 is what? Ulta of a rule number 1. What's rule number 2? This is one concave mirror, and if any line parallel to principal axis, it must pass through focus. What is rule number 1? Passing through focus become parallel. Rule number 2, already parallel to principal axis, and after reflection it will pass through focus. So it's a passing through focus. See, this line is parallel to principal axis, this x-axis is principal axis, this one is pole passing through focus. So this is rule number 2. Rule number 2 means line parallel to principal axis pass through focus. This is rule number 2. Now rule number 3. Rule number 3 is if line is passing through center of a mirror, it will retrace their path. Means whatever path it will take, it will return back by that path only. Means what's the meaning of that? This is concave mirror, this is the center. This one is center. So if any line passing through this one, this center, it will retrace that path. Means it will return back by this path only. This will return back. It will go like this path and return back by same path. So that will retrace that path. So a line passing through center, retrace its path. Means it will return back by same path. Whatever line passing through center, it will retrace their path, it will return back by same path, it will retrace that one. So this is third rule. Now fourth one, it's a famous one. Angle of incident is equal to angle of reflection. So 4 rules are there. This is fourth one. Angle of incident at this point is equal to angle of reflection. If we see that CP is a normal line. Why CP is normal line? Because this line is passing through a center. So any line passing through the center of a circle, obviously it's a normal line. So this is normal line. So it will strike over here. And so this angle is I and this one is R. Means both angle will be equal. In diagram doesn't look like equal, but both angle will be equal. I is equal to R because of law of reflection. So whenever you are making image using concave mirror or else convex mirror, so you need to remember 4 points. If light passing through focus, there are 4 points. First point is this one, passing through focus parallel to principal axis. Second point, parallel to principal axis, pass through focus. Third point, passing through center, retrace their path. Next point, angle of incident is equal to angle of reflection. So whenever you are making any diagram, any image using concave mirror, for that purpose, even if you are using convex mirror, in both the cases you need to use this 4 law. At least 2 you have to use. Which one 2 you can use, it depends on which diagram you want to make, but at least 2 law you have to use. For example, if I want to make one image of a object using concave mirror, let's say I want to make one image using concave mirror. So this is principal axis and this one is concave mirror, like this, and this point is pole, this one is called center, this one is focus, and I put one object over here, this one, and height of this object is AB. What I wanted to find out, where will be image of that object, where image will form. So we can say if I put object before this center, object I am putting before this center, So I am asking where will be image of this object. So for that I need to use that 4 law. First, second and third one. At least 2 I have to use. And image, we know what's the image? It's an intersection point of 2 reflected rays. So using that ray diagram, I find out intersection point of 2 reflected rays. 2 or more than 2 reflected rays, that will be image. Let's see this one. If line parallel to principal axis, if I take one line parallel to principal axis, so you people know, I told you that one law is there. If line parallel to principal axis, it must pass through focus. So this line is passing through. So this is incident ray, this one is reflected ray. Now if line already passing through focus, that must become parallel to principal axis. So if line already passing through focus like this one, this line, so this line become parallel to principal axis. So this line become parallel to principal axis. See this line 1, this one is 2, this one is 3, this one is 4. So if we see line 1 parallel to principal axis, it will pass through focus. Line 3 passing through focus, it becomes parallel to principal axis. So if we see line 2 and line 4, these two are reflected ray, and where reflected ray intersect, that point will be image. So this point will be image. So this one is image. Let's say this one is A dash, B dash. It means if object is before center, image will form between center and focus. So this is first image formation. First image formation using that 4 set of rules. So if you are using that 4 set of rules, so you can find out image. So this is the first image formation using that one. Okay, let's go for second one. Again I'll take concave mirror. Concave mirror, and object is where object will be at center. Object will be at center of this mirror. And let's say where will be image. So object will be at the center of this mirror, and I want to find out position of image. So this is the center of this mirror. This is center. This will be focal point, half of a center distance, that is called focal point. So focal point will be there. Now object will be here. This is the object. This one is object. A. I want to find out position of that object. So again I'll use that ray diagram. If light ray parallel to principal axis, so we know it will pass through focus. Light ray parallel to principal axis, it will pass through focus. Because rule is there, light parallel to principal axis, it will pass through focus. Now I named this one 1 and this one 2. So one is incident ray and second is what? Reflected ray. Now any light already passing through focus, it will become parallel to principal axis. So if light passing through focus, it will become parallel to principal axis. See? So it will go like this. Light passing through focus become parallel to principal axis. See this light passing through focus, it become parallel to principal axis. So let's say this one is 3 and this one is 4. Now 2 is reflected ray. Reflected ray of 1 and 4 is reflected ray of 3. It means I am telling 2 and 4, these two are reflected ray, means wherever these two ray will intersect, at that point there will be image. So this will be image. So if you see, image will be image. It means at same place of object there will be image. It means if object will be at center of a mirror, image will be also at center of a mirror. So that's all about this formation of image for today video.